In this skill, we're trying to figure out the conditions when a salt will be soluble. To use this, we're using delta G, the Gibbs free energy. And remember, if delta G is negative, that means the reaction is thermodynamically favorable. And that also means it's going to be spontaneous. So in this question, we're trying to predict the solubility of a given salt. We're told when the salt is mixed with water, the dissolution process, that means the dissolving process, results in a decrease in temperature of the mixture and an increase in entropy. So if we have a decrease in temperature of the mixture, that means that heat must have been taken in by the reaction, causing the solution to cool down. So decrease in temperature means heat absorbed in the reaction. If heat is absorbed, that means it's an endothermic reaction. And if it's endothermic, that means our delta H is going to be positive. On the other hand, if we had an increase in the temperature during dissolving, that would mean that heat had been released by the reaction. In other words, that would be an exothermic reaction, and the delta H would be negative. So in this question, since we had a decrease in temperature, that's telling us we had heat absorbed, meaning an endothermic reaction. In other words, delta H naught is positive. So we can fill that part in here. We're also told we have an increase in entropy. An increase in entropy, that means that our delta S naught is positive. Because we had a positive change. If we have a decrease in entropy, that means our delta S naught is negative because we've had a negative change. In this situation, we're told we have an increase in entropy. So that's telling us delta S naught is positive. So again, we can fill that in over here. We're next asked, what drives the dissolution of this salt? So remember, something that drives the reaction, those are going to be things that make delta G more negative. So looking at our reaction, we have delta H naught here. So if delta H naught is negative, that's going to make delta G naught more negative. So one thing we could have to make delta G more negative is to have delta H naught be negative. Then we also have minus T, the temperature, times delta S. Remember, the temperature is always going to be a positive number because it's measured in Kelvin, and that scale starts at 0 and goes up. If we're subtracting something positive, that means overall we have a negative number making delta G more negative. So if delta S is positive, we're then subtracting a positive number, making delta G more negative. So those are the two things that might lead to delta G being more negative, and therefore the two things that could drive a reaction. So in this situation, our delta H is positive. So that's not working to make delta G more negative. But we also have delta S is positive, and that is working to make delta G more negative because it's subtracted. So delta S being positive means that entropy is helping to drive this reaction. So the answer will be entropy only. Next, we're asked, under which conditions is the change in Gibbs free energy delta G naught negative for this dissolution process. So we're looking at which temperatures will result in a negative delta G. So we already know that this part is going to be a positive number. So this part is being subtracted. We need this to be bigger and this to be smaller. So when we do a smaller thing and we subtract a bigger thing, we get a negative number. So that's going to happen if T is as big as possible, or in other words, if the temperature is as high as possible. So we want a high temperature in order for this part that's being subtracted to be bigger than this part. That will result in a negative delta G. Next, we're asked, when is this dissolution process thermodynamically favorable? Remember, the whole point of delta G is that if it's negative, the reaction is thermodynamically favorable and spontaneous. So this will be spontaneous and thermodynamically favorable at high temperature. Finally, we're asked, under which conditions will the salt be soluble? Well, the dissolution reaction is the reaction where our solid salt dissolves into water. So if our dissolution process is thermodynamically favorable, our salt is going to dissolve. In other words, it's going to be soluble. So it's going to be the same conditions here. It's also at high temperature because that's when our delta G is negative. Therefore, that's when our process is thermodynamically favorable and spontaneous, and our salt is going to dissolve. So this skill is exactly like the previous skills we've done on the delta G concepts. The difference is that here we have a solution that's changing temperature, and we have to use the change in temperature as a result of the reaction to figure out if the reaction was endothermic or exothermic. If we have a decrease in temperature of our solution, that means that our reaction absorbed energy, meaning it was endothermic with a positive delta H. If we had an increase in the temperature of our solution, that means our reaction must have released energy, and therefore it was an exothermic reaction with a negative delta H.